Kia ora Year 11 and Year 10. In this video, I'm going to go through question 1A of the 2019 Tables, Equations and Graphs paper. So this question is really nice because it gives us some practice in transforming equations of graphs. There's no context in here, but if you master these skills, it will make some of the harder wordy problems much easier to do. So in this video, I'm going to look at 3 different transformations: horizontal shifts, sideways shifts, vertical shifts, which are really easy, and reflections in the x-axis. So there's a little bit of revision in here and there's a little bit of exam question. So the first part in here was a we achieved question where we just had to find the equation of the graph shown below. So that's using our skills from junior school maths. We've got a linear equation. So we know that the form of that equation is going to be y equals mx plus c. C is the y-intercept. So it's the value that when we've got x equals 0, what is y? Right, and we can see that in here because we can substitute 0 in for that x value. So in this graph, it's really clear that the y-intercept is here at -5. That tells me that the graph will have the equation mx take away 5. The next thing that I have to do is to work out what is the gradient or slope of that graph. Now we can see from looking that because it's going that way, that it's going to be a negative number. So what I have to do now is to find 2 blobby points and work out the change in the vertical distance between those 2 points compared to the change in the horizontal distance. So I'm going to use this point here, and then I'm going to look for another point. Now I could use that one there, or I could use this one here, or I could use this one here. It doesn't matter which one I choose as long as it's a point where I know the coordinates. So that's why we're going to use the blobby points or the whole number value points. So the point that I'm going to use here, I think I'll use this little one here. Draw in a wee triangle, and we can see that we've gone out 1 unit here. So watch your scale, but in this case it's nice and easy. The values are 1, 2, 3, 4. We've gone out 1, and we've gone from -5 down to -8. So we've gone down 3. So m is equal to the vertical change divided by the horizontal change. Some of you will know that as rise over run, right? So it's -3 over 1, which is -3. So that means that the equation of this line is -3x take away 5. So that's that first question done. Now the second part of the question is working with parabolas, but it's first of all we have to find an equation and then we have to do things to make the graph move. So step 1 is to find the equation of the graph shown below. So what should we know about that by this point in the year? Well, we know that it's a parabola, and so we know there are 3 different forms that we could have for that parabola. The first one is where I know the roots or x-intercepts of the equation. And if I know those, this is usually the easiest way to go. We also have to take account of how stretchy the graph is. So we need what we call, or what I call, a scale factor. Then there are the 2 other forms. This one is what we call expanded form. And we use that when we know the y-intercept, but not much else. And the third form is what we call vertex form, where I've got a number here, I've got this squared, and I've got another number on the end. But in this case, we're really lucky because we know the 2 x-intercepts. So what I can say here is that the first x-intercept is at 0 and the second one is at -4. So that means that my equation will be k times x plus 4. Right, so why is it plus 4 when I've got my intercept is -4? What is going on there? Well, the whole point of these intercepts is that what we're saying is that when x is 0, the value of y is 0. And so when x is -4, we get -4 plus 4, which gives me 0. 0 times all of this will give me a y of 0. All I have to do now is to find my scale factor. In other words, how stretchy is this parabola, right? Because I could have this one, or I could have a parabola that goes like that, or one that's even steeper than the one we've got here. So to find that scale factor, I need the value of another point on the graph, and I have to use a blobby point. Now here, I've got the vertex, so I might as well use that point. So that point is -2 for x, -4 for y. I take those values and I substitute them in. I get -4 is equal to the mystery number times -2 times -2 plus 4. That gives me -4 is equal to -2 times +2 times k. -4 is equal to -4k. That makes me really happy because k is a very easy 1. So the equation that we're given here is simply y is equal to x times x plus 4. It's fine to give that equation in that form. We could also expand it out, and then we'd have x squared plus 4x. Okay, and I could write it in vertex form, but I'm not going to do that in this video because I've got quite a bit of other work to get through first. Right? But if we want to put it into vertex form, we would use the method called completing the square. Now, the second part of this question is where we have to do 3 different things to this graph. So we're starting with y is equal to x times x plus 4. We want to translate or shift the graph 3 units to the left. So I'm going to go now to look at some GeoGebra that I did beforehand, and we'll have a look at how we can shift any curve left or right. So in here, the green graph is my basic parabola, y is equal to x squared. If I want to move everything over by 4 units to the right, then my new curve will have equation x minus 4 squared. So I'm taking my x and I'm subtracting off what I want to shift by to the right. So the reason that you can see that this works here is that I used to have my vertex here, and now I want to have it out here by 4 units. I used to have this point here, but I want to have it here. So by subtracting off 4 from my x value, my graph will get shifted back. All right, so to shift a graph rightwards, we're going to subtract. So if I want to shift y equals x squared right by 3, then the new equation would be y equals x minus 3 squared. If I want to shift it left by 2, which is what I've done in the red graph, if I'm going this way, my new equation will be y is equal to x plus 2 squared. So what I'm doing is I'm taking my x value and I'm changing it into x plus something or x minus something. So if we go back to our question, where are we? The first thing we have to do is to translate this 3 units to the left. So we've got x in here twice. We want to take the x and we want to think of it as having a little box around it. And we want to change that x so that it's x plus, x to the left, so x plus 3. So instead of having x, we're going to put a little box and we're going to have x plus 3 times a little box with x plus 3 plus 4. This looks silly, but it's going to work. So we get x plus 3 times x plus 7. So that's the first part of that done. Now we can see that pretty easily on the graph by saying that we used to have our roots here and here, and now we want to shove them over 3 units. So this one has gone to, oops, just turn that off. This one has gone out to here, and this one has gone out to here. The scale factor hasn't changed, so I'm still going to have my vertex down here, right? And now I'm going to draw that really badly. Not very good, but that's what's going on. Okay, so to do that with just by looking at the equation, we just make x change to x plus 3. So that's the first part done. Now the next bit is really easy. To shift down by 4 units, we're just going to take 4 off every number, right? So here, we're going to shift it down so that this at 0 is now moved down to here. This is moved down to here, and this one has moved down as well. When we're doing a downwards shift in an equation, it's really easy. So for example, on this graph, the green one is y equals x squared. Shifting up by 3, we just bang on a plus 3 on the end. Shifting down by 4 to this one, we're going to take 4 off. This is by far the easiest of the transformations. So down 4. So now we've done a cross. It's going to be y equals x plus 3 times x plus 7, take away 4. I can leave it like that, or I can expand it out, and I'll get x squared plus 10x plus 21 minus 4. That gives me x squared plus 10x plus 17. Now, if I want to reflect that across the x-axis, here's my curve here. Let's see, what have we got? So it looks like this, right? Every value that's down here is now going to be up here, right? Every value that's here is going to be down here. So here's my y value. I want all of my y values to be the negative of what they were before. So to do a reflection, all I do is I take y equals the original equation. And if I'm reflecting in the x-axis, oops, there is no, I'm going to go the negative of the whole equation, right? So if I had y equals x squared plus 5, what I need to do is to make things the negative of all of that, right? Not just that bit, the whole thing. I get negative x squared, take away 5. So back to the exam question, where are we up to? Well, we've got this. We've done the two hard bits. We've done these two shifts. And then the reflection bit is going to give me y is equal to the negative of that whole thing, which gives me x squared plus 10x plus 17, which gives me negative x squared minus 10x minus 17. So there you go. Hopefully that helps a wee bit. The Walker book has got some good stuff, I know, on all these graphing shifts. So has the Gamma textbook. So has Education Perfect, and of course so has Infinity Plus One. So go watch. This is a core skill for level 1 tables, equations and graph, and it's also crucial for level 2 algebra and for level 2 graphing. So it's well worth putting the time in to these transformation skills. Thanks for watching, and let me know if you've got any more questions you especially want done. This is especially for people in my tutor group.